co-chair for this conference. Dr. Zindel, please go ahead.
Yeah, thank you. Yeah, thank you very much, Maiva, for the kind introduction. And it's really very exciting to attend this session today, looking at AI and quantum computing later on from different angles, right? Let's dive a little bit into healthcare, the arena of healthcare. Where you hear from my side a little bit an overview, and later on from a very renowned expert from Siemens Healthineers, Dorin Komanicu, more details about AI and its application in healthcare. So just to frame this a little bit, every 1.8 seconds, there is a diagnosis on this globe about cancer. So that's a very frustrating message, in fact. Yeah. On one hand, on the other side, we see, of course, many opportunities to help those kind of patients. When you look at cancer, it's a pretty complex disease, in fact. There is no single disease. It comprises of around 200 subdiseases. So the diagnosis of cancer has really many flavors and is challenging from that respect, because it also demands complex decision-making for the clinicians, including the patients and sometimes also the providers. So it's a complex scheme. In addition, and I used to work in surgery for quite a while in the past, I noticed after 18 hours making complex decisions with those patients is really a challenge. And as we know now from the pandemic, healthcare workers are really under heavy stress and sometimes also burned out. In addition, there is a continuous growing need for care on the globe. I mean, we all know from the WHO that only half of the world population has access to care, or in other words, in non-served or underserved countries, nearly 50% have no access to quality care, which is also a great challenge for the mankind on the globe. So we have further already about AI, and certainly digitalization of the healthcare systems, and in particular artificial intelligence, is key. What you will hear later on also from Dorin is the recent developments we have done. It's pretty much around decision-making tools and companions which help clinicians, for example, analyzing CT or magnetic resonance data, image data, automatically, and using this data for proceeding with the patient further. We have done this also during the pandemic now in Lightspeed. It's a prototype development, but we wanted to be very fast here, and it's a development of CT-based data, CT data-based analysis of COVID-19 patients, including estimation of the severity of the disease for these patients. In addition, the other challenge is clearly for the physicians nowadays. You have to read 17 articles every day for 1 year to keep up with the exponential growth of knowledge in, for example, internal medicine. That's already pretty old data. I think the data today might be even more demanding, but managing knowledge is also a very important topic. And this is why we also use AI for mirroring a clinical pathway of a patient, for example, a cancer patient, using guidelines, for example, from the National Cancer Institute and so on, for prostate cancer, and help with these tools to not only use multiple data sources for an integrated diagnostics, but also coming up with an individualized treatment, following the evidence-based medicine based on the medical guidelines. So, and what you see here is also AI in its action. And I'm not sure whether you see the video. It's supposed to be a video, but it's AI-based auto-segmentation of nearly 70 organs in the body to make radiotherapy safe for these oncology patients. And that's also of great help, as you can imagine, because if you do this manually, it's really great burden. In addition, we also work heavily on the depiction of 3D data sets in the past, very often printed out in 3D prints, but now converted with cinematic rendering into 3D data sets. And I think you can all estimate what the benefits are when you as a surgeon work with such a tool and using 3D representation. And this is leading into something you will hear also from Dorian later in more detail, into what we name the digital twin. And in short, it's a representation of the human being. And we have started with the heart. We have gone now into the liver. You see here a liver. And when you treat the liver, it's a representation, a digital model of the liver, where you can simulate treatments based on the individual data of the patients. So you can do this also with the heart and can see whether some therapeutics are helpful and it's a responder or a non-responder. Hence, you can save a lot of money in the healthcare systems. So this is, as you can imagine, a longer-term vision. So it takes us certainly quite some years to build this out. But we are very excited about it based on first studies we have done, not only in the heart, but as you have seen, also in the liver. And as you can imagine, mirroring the human being on an individualized fashion and using AI, by the way, to really monitor the data constantly and to even predict that a disease could come up is a great potential for the human beings on the globe. So in addition, what is needed, you need computational power. This is a picture, I think, close to Princeton in Eugene, I guess. Dorian will talk about this, and the power significantly more than the computer I'm currently using. I guess we are talking around 44 petaflops, if I'm not wrong. But you need really reckon power. And what you also need, and I think Killian Cross talked about this quickly, and I liked it very much, it's also about building out trust and data security principles, right? Which help building out the trust, not only amongst the expert, not only amongst the patients, but also in the societies. So we are dealing in healthcare probably with one of the most sensitive, with the most sensitive data. This is personal data, this is private data, and it needs to stay private when we talk about healthcare data. So, and in addition, safety matters very much. We are developing robots in the USA, in Boston. This is Corindus. And it's an intravascular robot which can be remotely controlled, not only here in the proximity, but also in the future via internet and even transcontinentally. So security, as you can easily imagine, matters very much. So this is a topic which is giving us quite some challenges. We believe we need to do data security by design. So it's really about developing a product already in a very, let's say, safe design and fashion. Talking about quantum computing, I'm personally very excited about this topic because I believe there is a huge potential in the topic. Also, it's not, let's say, commercially available, as we have heard also from Congressman Bill Foster. What I believe is here a little bit a good comparison when we think back to the Wright brothers, and they flew in 59 seconds, as I learned, 260 meters. No one in 1903 would have ever believed that 100 years later, people would fly 200s in such a big airplane and would fly even, you know, transcontinentally or to Asia or to the West Coast, wherever. So very impressive. On the other side, another example, Bertha Benz, the wife of the inventor of the famous Benz and Mercedes-Benz, drove with this vehicle long distance. It was called long distance in Germany, 121 miles from Mannheim down to Pforzheim, which was at this point in time sensational. She took the two sons and drove down, which is also, by the way, a great example for diversity and inclusion. I think it was the first step towards the right direction. No one would have ever thought at this point in time that nearly autonomous driving could happen now. This is a 9 days trial with a car, 99% autonomous driving, and it drove actually from San Francisco into New York City. And then my last example, and this is heading into the quantum computing arena, in 1941, when Konrad Zuse, who was a German civil engineer, a very intelligent one, as we all know, invented the first functional processing kind of computer. And you see here by the way, a rebuild of this computer, and you see here his son, Horst Zuse. And when they invented it, I think no one would have ever thought about quantum computing at this point in time. So we all should take it rather seriously and should see this as a potential disruption in the future. And I believe it can be also the next big thing in healthcare. The good news is I mean, for me as a medical doctor, I'm happy to read. I don't need to understand it. This was a citation from Richard Feynman, who received the Physics Nobel Prize in 1965 for his great fundamental work in electrodynamics of quantums. And this was, let's say, the groundbreaking work for quantum computing, as we know. And the potential is huge, and I can only touch quickly on what would be conceivable, not only supersonic truck development, where you can save a lot of money, but also accelerate. I think the pandemic is showing the potential, but also three-dimensional protein folding is, of course, something where you can easily compare proteins. You can be much faster in research. Communication and safety matters very much. Famous Alice and Bob, as we all know. It can be seen as a risk because encryption might not matter anymore because you can really hack it in relatively short period of time with quantum computing, as we all know, but it's also able to serve as a very safe communication between Alice and Bob. So it has also a huge potential for safe data transmission. So research is underway, as I'm learning, and I'm sure we will hear today more about post-quantum cryptography, which is already a kind of answer and a very important one for various industries. So, and one final example here at the end of my presentation, can it be also of help to do traffic optimization for stroke patients? Because stroke is a very urgent, time-critical disease which pops up immediately, and you need to help in minutes and in hours in order to protect brain tissue. Being fast matters, and can quantum computing also help optimizing the traffic and making, let's say, free lanes for those kind of patients in the future? I could talk about more potential applications, but it was just meant to be an example. And with this, I want to thank you for listening to me, and I would like to hand back to Maeva. Thank you, Maeva, and thank you for listening.